Everybody, this is Mrs. Dinkelman again, and we're in Unit 8, and we're talking about approximations for integrals. So usually we use rectangles and trapezoids. That should be review from Calc AB, but we're going to add in Simpson's rule for a little bit during this section. Simpson's rule is also not on the AP exam, just like I'm thinking of trig sub because I just made that video, but it is helpful to know in case you skip through a Calc 2 class. So I just want to remind us a little bit about using LRAM, so the left rectangle approximation method, RRAM, so right and then midpoint, and help you out maybe a little bit with the calculator to make sure we know what's going on with all of those. So I'm going to start straight from the calculator here. Just a quick reminder, since we are talking about sine, we want to make sure we're in radian, so it's really easy to check at the bottom of your screen. If you're in degree, it will say DEG there. And that's just a change that you can make in the mode. You just need to scroll down here where it says angle. I'm going to go ahead, since I'm going to be using this same function over and over again, I'm just going to put this into y1 because that means I don't have to type the sine of e to the stuff very often. So sine of e to the x divided by 2, and then we'll make sure that looks right. So that's in there, and then we can go back to the home screen and we can use that. So what I like to do on these is to think about all of these are with n as 8, and I like to go ahead and just write out what my intervals are. So -2 to 6, that's a span of 8, and so when we divide that into 8 rectangles or trapezoids or whatever we're going to use, the width of each of those, or if it's a trapezoid, technically it's that height, is all going to be a 1. So especially for when I get down here to the midpoint, this is going to be helpful. So I'm going to go -2 to -1, -1 to 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, I'm going to run out of space, 4 to 5, 5 to 6. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So sometimes it just helps me to have those. It's not really a visual, but it sort of is. I can kind of think about how those work. So with the left, remember we're going to use all of the endpoints on the left. So if we look at each of these intervals, we pick the left endpoint and use that to find the y coordinate to find our height. So on here, again, our width is 1. So what we could do is just put a 1 on the outside in parentheses. It's a 1, so we don't really need that. But if, let's say, the width was a half, or if it was 2, it would be helpful to just put that 2 on the outside and not have to think about it. Or we could just multiply at the very end as well. So here what I'm going to have to do is I'm going to have to figure out what's going on at each of those left endpoints. So I have to plug that -2 into that y1 that I have in there. So you can see here I just grab the y, the 1, and then -2. And then I'm going to do -1. And I have to keep doing this all the way until I get to this last one. I'm going to use a 5. And that's where I know I will stop. So there's the 0, 1. Feels like a lot now that I'm doing it. Let's see, that was 2, so 3. Imagine if we had to be typing this every time, though. It's really nice to be able to have that in that y1 and not have to worry about it. Okay, so I think that's all of them, but you guys can double check me, and I'm going to do diamond enter here because I'm in auto. So 2.725. I'm going to go ahead and write that down just so we can kind of check our work on all of them and make sure that seems right. 2 point, I don't know why I jumped up there. Okay, 2.725. Okay, so now let's try the same thing, but now we need to use all the right endpoints. So to me, the only thing that's different is if we come back here to the beginning, we're not going to use this -2, so we can actually get rid of that guy. And I know I could just replace it, but in my mind, I want to start with that -1, and we're picking all the right endpoints. And so we need to add in that y1 of 6 now. Okay, and I'm going to go ahead and diamond enter here. So 3.310. Okay, so now the midpoint, this is when this is really helpful for me because I can kind of write down what all the midpoints are. So -1.5, -0.5, 0.5, 1.5, 2.5, 3.5, 4.5, and 5.5. so those are all the midpoints. So let's see if I can go in here and just kind of use what I have here. Okay, so this 5 needs to become a 5.5, and then a 4.5, 3.5, 2.5, 1.5, 0.5, -1, hopefully 0.5. We'll double check that one. Oops, this one, let's see, what do I have? 0.5, I need -0.5 here. Let's just make sure we have that right. -0.5. Let's see here. Oops, too many negatives. I wondered if I was going to do that. Okay, so -0.5, and then I need -1.5. So let's add that one in here. y1 of -1.5 plus, and then we're going to diamond enter that one. So hopefully it's somewhere in between 2.127. All right, let's make sure I have that right. It could totally be right. It just seems odd to me. Make sure I have all those right. 3.5, 4.5. Okay. You see a mistake on there, you just let me know. I was expecting it to be a little bit more in the middle, but that's okay. 2.127. 2.127. Okay, so with the trapezoidal method, remember that we need to remember, and I'm just going to insert up here because I have lots of space, that the area of the trapezoid is, it gets upset with me after a while, base 1 plus base 2 divided by 2. It's averaging the bases times the height. And so for us, the height of each of these is going to be 1. And the bases are going to be those y coordinates that we found earlier. So we can do this by hand, where we start writing. For that first trapezoid, we're going to have to figure out, starts at -2, right? So we're going to have to go y1. I shouldn't do y1 as I'm writing here. I should just say f. We'll call it f of -2 plus f of -1 divided by 2 times the height. And we can kind of just do this over and over again. Or we can start to notice that we have a pattern here, like all of the heights are 1. We're going to divide them all by 2. The other thing I want you to notice is, oh, I have f of -1 twice, and that's going to happen all down the line. So what we can do, and I'm going to go ahead and do that on my calculator. Now, this only works, by the way, this formula only works if the heights or the widths in between the delta x is all the same. And maybe there's one in the assignment that I can show you that you actually have to write it out like I started here. So again, I think the heights are all 1. I'm going to divide all of them by 2. And then I'm going to have y1 of -2. But with the next one, with the f of -1, I'm going to have 2 of those. So I'm going to go ahead and call that 2 times y1 of -1. And that's going to happen all the way until I get to the end one. So if I kind of want to use this formula, I can. If I just don't, and I'd rather have the visual and just write it out, that's really okay too. It's just sometimes there's enough of them that I get annoyed or frustrated enough that I want there to be a little bit of a shortcut with that. So we're on 2, 3, and then we have another way to check our work to make sure it seems right, which I'm going to show you in a second, and can also be a shortcut in some cases. Okay, so there's 5, and then the last endpoint is 6. We only use that once because it's only on one side. And then let's see, we'll make sure we diamond enter here. 3.017 for that answer. Okay, and the way we can check our work is that our trapezoid really should be the average of the left and the right approximations, and that's because the area is an average of the left and right endpoints. So of course this is going to have some rounding error, but if I go up and grab the actual, I know it's rounded somewhat, but not as much. Let's see, I forgot to put a plus sign down there. I'm going to go ahead and do that. So if I add those two together, divide by 2, hopefully I can check my answer, 3.017. Okay. So now we're going to use Simpson's rule, which again is not part of the BC curriculum, but is something that you should know in a Calc 2 class. So Simpson's rule actually uses parabolas. You can see the formula there. I'm just going to go to a quick picture that I found online that kind of shows us what Simpson's rule is doing. What it's doing is really picking 3 points, making a parabola under those 3 points, and then calculating the area under that parabola. And so you can see here this next one, it picks 3 points, makes the parabola, then we would find the area under that. In fact, if we're in class, we will do an activity where we do that by hand and kind of see why Simpson's rule is really nice to have the formula. So same function here, we're going to go with n is 8. This pattern that goes 1, 4, 2, 4, 2, 4, 2, so on, and all the way back to 1 needs to hold. In fact, the second to last one needs to be a 4, and we need to make sure this 4, 2, 4, 2, 4 pattern holds and there's no doubles or anything in that one. So on here, I'm going to go ahead and type in what we have. So our delta x is still 1, so in this one we're going to have 1/3. And this really should be a more accurate representation because not only does like in trapezoids, the nice thing is we match the increasing decreasing behavior. So it should be a little bit more accurate generally than the rectangles. Simpson's rule is also going to match the concavity. So in a lot of cases, it's going to be more accurate, again, depending on what our functions look like. Okay, so I still have that in y1, and we're going to start with -2. And remember the next one, we go 4. So that's going to be when we plug in -1. And then 2 times the next one. So 2y1 of 0. 4, y1 of 1. 2. This is when y1 of 2. And then plugging in a 3. Plugging in a 4, and again, as the pattern holds, the second to last one should end on that 4, so that's when we plug in 5, and then finally the last one, just y1 of 6, no multiplying, and we'll diamond enter here. So 2.157. I guess I should have looked if I needed to round that. Okay, perfect. Okay, so let me there was one comment I wanted to make earlier, and that was just looking at the trapezoids when they're not an equal increment. So on number 4 in your assignment, this is a great example of a problem that you cannot use that pattern because the height of each trapezoid is going to be different. So from here to here, we have a 2, and then a 3, and then a 2, and then a 3. So we can't use a formula. We're going to actually have to write out the formula for the area of each of the trapezoids as you do that. So go ahead and get going on the assignment.